Hello everyone. So in this video, let us talk about the first three problems of the latest Leetcode Biweekly contest 77. So let's start. Okay, the first problem is count prefixes of a given string. So the problem in simple terms, I'll tell you. The problem statement goes like this: that you are given a array of words as a string, as well as a different string s that is also given to you. Now, the overall problem statement asks you that you have to find out that if you take out every prefix of this given string, how many times that given string is present in this words array. That's the overall problem. Now, if you can see that, what are the different prefixes of ABC? It's A, AB, and ABC. Okay. Now, if you find out A, how many times A is present inside this whole array? Only one time. Now, AB. Now, AB is present here and ABC is present here. So, all the three prefixes are only occurring once. So the total times all of those prefixes are occurring is equal to 3. Now similarly for this, now what you can see is that the prefixes are A and AA. Now for A is present 2 times and AA is present 0 times. So the sum of all of them is 2. So the answer is 2. So you just have to do that. Now the constraints are pretty small, so you can do this in a very brute force way. So I will not go in the what exact actual logic around it, but the actual simple implementation here is to just do this in the very brute force way, find out all the prefixes, and for all the prefixes just find out how many times a given prefix is present in the whole words array, and just return the count and just add all of those counts. That's the overall solution. So I'll take on to the good part now. Now what I've done here is that this is the count prefix function that will be called. Now in this is the answer variable that will store what is the total number of prefixes that are present if we find out in the answer vector, or like in the words array. Now we just iterate over all the substrings. So I'll find out all the substrings using this substr function from C++. Now it will present all the prefixes. Okay, and we just call this check function. Now this check function take every prefix. So what I've done here is that starting from the 0th index, every prefix, so every substring starting from 0th index, so first character, first 2 characters, first 3 character and all. So it is like a for loop taking out all the prefixes and just calling this check function with this prefix and this words array. Now this check function will just take this substring and just iterate over this words array and check how many times this particular substring is present in this words array, and just increment the total and just return the total. So whatever is the total number of times this particular substring is present in the words array, I'll just like add all of those total times and just return the total answer. That's the overall solution for the first problem. Now moving on to the second problem, minimum average difference. So the problem statement goes like this: that you are given an array. Okay, now for this particular array you have to find out the average difference. Now the average difference is the absolute difference between the average of the first I plus 1 elements and the n minus I plus 1 element. So if you let's say that if you are on any given I, then the summation of all the left elements and all the right elements, but you have to find out the averages. So you have to find out the absolute difference between the average of the first numbers that are I plus 1 numbers and the n minus I plus 1 numbers, and you just have to find out the absolute difference between all of this, and you have to just return the minimum absolute difference index. Okay, so among all the minimum, like among all the absolute average differences you find out, you have to return the minimum, and for that minimum you have to just find out at which index that is present. So I'll tell you with an example, it will become more clear to you. So what you can see is that this is the array. Now if you find out let's say starting from the first I, so if you take for the first I, what all other elements that are to the left of it, including this particular element. So including this element, the element on the left of it is only 2, and on the right of it is 5, 3, 9, 5, 3. So on the left side, you just have to find out the average. So average is the total, like the total sum upon the total number of elements. So the total sum is 2 and the total number of elements is 1 because it is only consisting of one element. On the right hand side, it is all the elements, that is 5, 3, 9, 5, 3, and the total elements is 5. So the first thing is this number divided by 5, the second number is this, and if you just have to find out the absolute difference between these two numbers. Also, when you find out the averages, it should be rounded down to the nearest integer. So like if you like whatever, if it doesn't divide, you have to round it down to the nearest integer and just find out the absolute difference, and this is the answer. So that is the average difference. This is the average difference. Now you just find out the average difference for all the positive indexes. Now this is for the I equal to 0. Now I equal to 1 is the summation of the first 2 elements divided by 2 and the summation of all the rest element on the right hand side. Now I equal to 2 is summation of the first 3 elements divided by 3, like total number of elements, and the summation of all the rest of elements divided by the total number of elements, and whatever is the answer, that is the average difference. Now among all of those average difference, what is the smallest? The smallest is, as you can see, that this is occurring at index 3. So what is among all of those smallest, like smallest average distance, you just have to find out the index of that. So index is 3, so the answer for this is 3. Okay, so that's the overall logic. I like the problem for this problem. I like the overall explanation. Now how to solve out this problem? You just have to find out the prefix and the suffix sums. Okay, because you have to just find out for every I what is the total sum of all the elements on the left side and on the right hand side. Okay, and then because you know what on given I you are, so you know how many total number of elements are on the left side and on the right hand side of the particular I, and then you can easily evaluate this particular expression and find out the average difference. And among all the average differences, you just have to find out what is the minimum, and for that particular minimum you have to store the index. That's the whole solution. So nothing too much complicated here as well, so I'll take it on to the code part directly. So what I've done here is that you have to first find out all the summation of all the elements on a given I from left hand side and right hand side. So it's like a prefix sum and prefix sum and suffix sum. So that's what I find it out here. Okay, prefix sum and suffix sums. Now you have to just find out the minimum of all of those average differences. So you have to just initialize it with a very large number. Then this is the indexes. Then v1 is summation of all the elements to the left of any given I. So that is left of I only, because that's the prefix sum. So prefix sum still I divided by total number of elements. So because it is I equals 0, because on the first element, let's say you're on the first element, so total number of elements you have taken is 1. Okay, but I goes from 0, so you have to add I plus 1, because I plus 1 is the total number of elements, because I is 0 plus 1, so that you know that how many elements are there on the left hand side. So that's the overall number on the left hand side. Similarly on the right hand side, but there is one catch here. When your index is on 0, you are taking this particular element as well, but when you are on the last index, you are taking the whole array on the left hand side, so as you can see, and the right hand side becomes 0. Now if you are doing the same thing, like dividing it by the total number of elements, if you are doing the same thing, then what will happen is the total number of elements for the last element is 0, but you divide it by the total number of elements that you are taken, that is also 0. So 0 divided by 0, that is not physics, like it will get you an error. So it's better to only iterate till the last, like the second last element, and for the last element you have to just make your right value equal to 0. So that's what I've done here, is that if my I is less than the last index, then you just have to evaluate the right value by the total number of right elements you have divided by the total number of elements you have taken on the right hand side. But when you're on the last index, that is n minus 1, you will only take 0. So that is the overall like evaluation call that I've taken. Okay, and then you have v1 and v2, that is on the total number of elements average on the left hand side and right hand side. You just have to find out the absolute difference of them, and this is the v that you want to calculate out. Now if this v is smaller than the total, like the global minimum that you have been calculating till now, you just update your mini and the index, because you just have to find out the smallest average differences among all the total elements you have and just return the index. So that's the overall logic and code part for this problem as well. Let us move down to the third problem. So the third problem is also not too difficult. Count unguarded cells in the grid. So the problem statement is very simple. It says that you're given a grid n cross m. Now in this particular grid, what you're given is that there are two types of entities you can assume. The first entity is a wall and the second entity is guard. Okay, so you can see that there is a complete room, you can say, and in this particular room there are different grid blocks. Now every block can be associated with either it is empty, it is occupied by a guard, or it is a wall. Okay, now what a guard can do is that the guard can throw light in all the 4 directions. Okay, in like all that, like left, right, top, bottom, and it will only stop the light when it hit a wall. Okay, so as you can see that this guard will like throw the light here, so there is no like room here, so nothing here, and this is a wall here, so nothing here. Okay, so this guard is throwing light here. Now this guard can throw light here, here. Okay, in all of the directions. The other one is wall. Okay, now this is a wall, so this is a guard. This guard will throw light here, and this is the wall. So you can see that these red blocks are the one that are throwing out, like that are blocked, because like you cannot walk on them, and these are also guard block and this is wall block. So you just have to count out how many green blocks that are left, that is not wall, like all of those grid points that are either like not occupied by guard, wall, and also they are not seen by guard vision also, because these red blocks are the blocks that can be seen by guard. Okay, so you have to find out what all are the blocks that cannot be seen by guard, as well as they are not like neither guard as well as wall also. That's the overall problem. So there can be multiple approaches to solve this problem, but what I find out easy is that what you can actually do is, I will like draw it out. So I will draw a grid here. Okay, now let's say that this is a guard. Okay, and this is a wall, and this is a guard as well. Now because this is a guard, it will throw light in this particular direction, that is, this direction. Okay, now this light will keep on going on the left hand side till a wall is hit. Now if a wall is hit, then this light will not propagate any further, but it will start propagating again if you find out a guard again. So if you find out a guard, then it will start propagating on the left hand side again, like on the right hand side again. So what you can do here is that you can iterate this whole grid first on the left hand side for every row. Okay, for every row. So let's say starting from this row. Okay, you just make a counter. Let's say a counter is equal to k equal to 0. Okay, whenever you see a guard, it means that now from the right hand side of it, because you're iterating from this grid, so you have a grid. Okay, then you first iterate over this grid from left to right, from left to right. Now in left to right, you iterate over every row. Now for every row, let's say we're talking about the first row, zero index row. For the first row, what you will do is that you have a variable, let's say k equal to 0. Whenever you see a guard for this particular row, which means that now because there's a guard, it will start throwing light on the from left to right, from that particular point to the right direction, because there's a guard. So all of those grid points that are on the right hand side of guard will be marked as crosses now, till you hit a wall. So when you hit a wall, you will make your k equal to, let's say 1, that, yeah, or maybe -1, whatever you can say. Now this is the wall, now this light will not propagate. So if there is a block here, so let's say that if I can say, if so where is the brush? Okay, so let's say that this is not this is not the guard, but the guard is here. Let's say the guard is here. Okay, this is the guard, and this was an empty point. Okay, now what will happen here is that this is the empty point. When this light will start propagating from left to right, this point will be like seen as the point. Okay, I will take this as a pen. This is a pencil, sorry. Star, what is taking star? So we're taking it as a pencil. Okay, so what we're trying to do here is that, let's say that this is not a particular guard, but the guard is here, as let's say, and this is an empty block. So we are taking that now my k is equal to -1. When I iterate over from this point to this point, my k is -1, which means that the light is not propagating from this guard to this point. We will mark it as that this is safe point. But this is again a guard is here. So from on the right hand side to this guard, light will propagate, and you will mark it out as crosses. Similarly, you will do this for every row. So this is a guard here, starting from here. So this will be an OK block. And this is a guard, so it will start propagating all the light, and we will mark all of those blocks as crosses. Now if there is a guard here, so all of the light can, like, this is OK block, this is an OK block. Now the guard will start propagating, so this is an close block, and this is, let's say, a wall here, so this is an OK block. So you will now mark all the blocks from left to right. Now similarly, you'll do it from right to left also. Okay, from right to left also, because it can happen that, let's say, there is some guard here. Okay, and you will say that this is the guard, this is the wall. Okay, and this is a guard and this is a wall. So what you will do, and this is the wall again, and this is a guard. Okay, so so what you will do, you will say that this is the guard, so this will throw a light till this point. This is the wall, then there is nothing, so all of these blocks are valid blocks, and this is the wall, so all of these are valid blocks also, and then this is the guard. So after this is the not valid blocks, but these are also not valid blocks because this guard can also throw light from the like from the right to left. So these are also not valid blocks. So what you have to do is that for this given grid, you have to do from left to right, right to left, top to bottom, bottom to top, for all the, like the same condition is done, but in all the 4 directions. And then whatever is the final answer, you have all the empty blocks that you cannot be reached. That's the final answer. That's the overall logic. I'll take it down to the code part so it will become more clear to you. So we have made a, like the whole array, a whole matrix, sorry, of n cross m. This is A. Then we have just marked out the blocks that are guard as well as wall in the original matrix that we have made, and everything is initialized to 0. And we have marked guards as 1 and the walls as -1. Okay. Then they have made a k variable. Then what we have done here is that we have done a for loop from left to right. So for every row, my k is starting at 0. Then what I've done here is that if I have encountered a 1 means a guard. So 1 means a guard. So what it means that if 1 means a guard, I will make my k equal to 1. So now the pointer has turned to 1. And if I find it a wall, I will make my k equal to 0. Okay, so it's like a k is, if a k equal to 1, now in this condition, and now if k equal to 1 or k equal to 0 will be flipped from here. And for all the other blocks which cannot be reached, so there are some blocks that are guard, some walls, and all the other blocks that are like not 1 or 0, that are originally 0. For all the blocks, when we get in this condition, if it is a guard on this particular one, so it is a k equal to 1, which means that we have already seen a guard. So that particular block a of ij will turns out to be 2. 2 means that it is a bad block. We will not reach there because that is a block that can be seen by the guard. So we have 3 entities here. 1 means the guard, -1 means that is the wall, and 2 means that that particular block can be seen by the guard. So that's what we have done from left hand side and right hand side. Similarly, moving from like right hand side for every row. So for every row I equal to 0 till I equal to n. For every row now we move from right to left. Similarly now from like bound to top and from top to bottom. So we have now merged everything down, and now after doing this iteration from all the 4 directions, it's just an O of m into n only, just 4 times. And then whatever blocks are left that are 0, because those cannot be like touched by these guard positions, or these are neither like walls or guards, all those are clear points. So we'll just iterate over this grid again, and whatever is turns out to be 0 that has not been touched, the answer is that we like add all of those blocks out, and that's the particular answer. So that's the overall solution for the first 3 problems. So thank you for watching.